Okay. Afternoon, guys. Last period of the day. You guys excited? Hi, man. I am. I'm so excited. One more period to go. Me too. Me too. Me too. We're all excited. Guys, I'm testing your your writing skills now. All right. I Who wrote that? I want to make sure you're answering the prompt. Make sure you're answering the prompt. Okay. Also, yesterday there were less students overall. Did I say that? I thought I said that. Yeah. In each and every single class. I also did record the lesson yesterday, but I didn't realize how bad my laptop audio was. You guys didn't say anything. You guys didn't mention how bad the audio was at all. I like these. Well, I like these answers though. I like that. I like the fact that you guys are putting effort into this. It's good.
You
It's good.
post the poll?
I posted a yes.
Can you
I what?
repost it?
Sure. What the hell? Wait, what is this? Oh,
It's like
that's not self-advertisement, by the way. Hold on. I'm trying to copy my poll, but I can't copy the poll. That's not self-advertisement. Please don't go to that link. That's the point. Yeah, but the audio quality on yesterday's lesson was pretty bad. I like these responses so far, though. I like it. I mean, some of you guys are on and off. Good. Like being able to describe this is really good, right? You do actually want to be able to describe what's happening in the image. So let's move on. Let's continue. No, it doesn't. You'd have to have a
Depends.
lot more.
Yeah, you have a lot more subs and views to get monetized and stuff like that.
Yeah. Pretty sure Samanja was just asking like me personally though. So that's why I say no. That's not my intention anyway. Good. I like what you guys are ready. Like again, your potential energy turns into kinetic energy, but as it turns into kinetic energy, you are losing energy due to internal energy, right? You are losing some energy, and eventually, when the ball stops bouncing, all that energy turns into internal energy, right? So again, some of you guys, yesterday was a lower than expected turnout. So because yesterday was less than expected, It's like a 50% turnout yesterday. I don't know. I don't really understand why. It was like that for all my classes, but I don't know. But whatever. So we're just gonna watch this video, right? It's gonna be a review of everything we've done so far, besides for internal energy.
Look at that view. We're here at the scenic Morgan Falls Hydroelectric Dam, located along the Chattahoochee River in Sandy Springs. The gravity-type dam and powerhouse built in the early 20th century was one of the first hydroelectric power projects in Georgia, and it's still in operation today, as part of Georgia Power's network of electricity-producing plants throughout the state. This is a great place to tell you about the law of conservation of energy, not to be confused with energy conservation. Energy conservation is what you do when you insulate your home and try to save energy, like heating and air conditioning. This is different. The law of conservation of energy is all about where energy comes from and where it goes. The law states that energy cannot be created or destroyed. It can just be converted from one form to another. So let's follow the energy. I'm in the powerhouse of the plant that uses the stored energy of water in the reservoir to create electricity. A large pipe carries water from the reservoir to turbines in the powerhouse. The flowing water turns a propeller-like water wheel or...
Why do you think the water falls down?
To turn the wheel.
Okay, the purpose of the water to fall down is to turn the wheel, but why does it fall down? What's causing the water to fall down? Yeah, it's forced due to gravity, right? So you can say that the water has gravitational potential energy, and then
or turbine, which is connected by a shaft to the generator, which spins and produces electricity. This turbine is normally underwater, but we've been given a look inside the penstock that houses the turbine. After the water spins in the turbine, it is discharged through a tube and returns unaltered to the river below the dam.
So you see this, right? You see the water going downward, which in turn turns the turbine, right? Which basically you're converting gravitational potential energy into kinetic energy. And then you're turning this generator in a circle, which in turn generates electrical power. Now we'll talk about how electricity is generated in like around 2 units, because again, that's very specific. We generate electricity because we understand how electricity works. So we'll talk about that later, but you can clearly see here that you're converting kinetic energy into electricity just by building a dam, right? Just by having the water at a higher level.
The electricity produced by the spinning generator is conducted to the power transformer, where the voltage is increased. The high voltage electricity is fed into Georgia Power's transmission lines and distributed throughout the region. So how does this illustrate the law of conservation of energy? Water flowing through this plant
and you can turn the generator in a circle through multiple methods, right? Steam engines, windmills, right? You see like those huge wind turbines that go in a circle, right? Using natural energy.
Is turning gravitational potential energy
renewable
into kinetic
energy,
energy
not natural,
and eventually
renewable.
into electricity. Remember the relationship between gravitational potential energy and kinetic energy when you have a falling object? Gravitational energy is transformed into an equal amount of kinetic energy. Here, however, it's not quite the case. Here, you end with less kinetic energy than the amount of gravitational potential energy you started with. But why is that? Where did that extra energy go? When water hits rocks, water scatters into a spray, and some of that energy is used to vaporize water into the atmosphere. The water also bumps into itself and the walls of the pipes, creating friction, which produces heat and sound energy as it flows. There's also friction within the generators as the electromagnets turn. The energy isn't lost, it's still there, but it's difficult to measure all of it, and it's not available for useful work. Non-conservative forces cause energy to be converted into forms.
So again, what he's saying is basically the same thing I said yesterday. You're not losing, this energy doesn't just disappear. It's basically just being lost as heat. Now I know he said energy is not being lost, but that's just like so he doesn't mislead people. When I say energy is lost, I don't mean like it's just destroyed. I just mean that the energy is lost as heat or thermal energy, right? That's what I mean. But he's just trying making sure that he doesn't mislead people. This thing that he's going to be talking about right now, I'm not going to test you on it. I'm not testing you on these things.
That cannot be easily regained. Forces like friction, air resistance, and water resistance are non-conservative forces. They're more difficult to harness, making it hard to get them back in the form of usable work. Work done by non-conservative forces depends on the path taken. On the other hand, conservative forces cause energy to be converted into forms that can be regained. Examples are forces like gravity, spring force, and the electrostatic force. They do the same amount of work on an object being moved no matter the path taken. For example, gravity does the same amount of work on the water moving through the dam, whether the spillway taking the water from the top to the bottom is a steep straight shot or a shallow curving flow before the water gets to the bottom, since the total vertical drop the water has traveled is the same. A long curving path produces more friction, which is a non-conservative force, and thus produces wasted energy. Okay, so let's see why it's worth knowing about all of this. Let's say I want to know the velocity of this ball right before
Yeah, I
it
don't
hits the
care
ground.
because he's just going to enter practice problems right now, and I don't really care for that because I'm gonna do practice with you guys. All right, so let's get started. Yesterday we talked about the concepts of internal friction, right? And I mean not internal friction, but internal energy. And today we're going to go into practice problems. Yay! So where are my notes? You know I'm always going to ask you that first. What are my notes here, guys?
Your height is 20 meters.
My height is 20 meters. Good. Right, you drop from a height of 20 meters. Good. Your force due to gravity is 1 Newton.
Kinetic energy is 10 joules.
Kinetic energy is 10 joules. Can you be more specific with that? Because my kinetic energy can change. Where exactly?
Before the ball strikes the ground.
Yeah, before the ball strikes the ground. So I'm going to name that kinetic energy at the bottom. What else? What am I trying to solve for, guys?
You're trying to solve for eternal energy.
Trying to solve for internal energy. Good. Q. And for most regions problems, you're going to solve for internal energy at the bottom, like after everything is over, right? How much energy did you lose? So you're going to set this up the same way you did for homework 5.4. You're going to solve questions the same exact way. So you have a baseball that drops down from a height of 20 meters. You got to go and pick up your little brother now? Sure. Okay. So your total energy is equal to potential energy at the top plus your kinetic energy at the top plus your internal energy at the top. And what's my potential energy at the top? What formula do I use? mgh. What's my kinetic energy at the top? Has my ball moved yet? It's 0. Yeah, it's 0. My ball hasn't moved yet. Again, the formula for kinetic energy is 1/2 mv squared. If your ball has not been dropped yet, well, my velocity is 0. If my velocity is 0, then my kinetic energy is 0 as well. And we don't have any internal energy. We haven't lost it yet. The ball has not moved. You can basically assume that your internal energy at the top is 0, guys. I'm just writing it out to be consistent, to show all my work. But you guys can basically assume for almost all regions questions, your internal energy, you haven't lost any energy yet. There is no energy being lost if you haven't even moved yet. So that's pretty much always going to be 0 for regions, okay? Your internal energy at the top is always going to be 0. Your kinetic energy at the top is most likely always going to be 0. Because for regions questions, you usually almost always start at rest anyway. So it doesn't really matter. You almost always start at rest. Also, your force due to gravity is mg, which is why Fg replaced mg here, okay? That's why. 120. So you have 20 joules of energy at the top. That's your total energy. Questions, guys, about what I just did so far? I still haven't answered the question yet. Good. So now we get on to actually solving the problem. So we know what our total energy here is, 20 joules. What's my potential energy at the bottom? Should be easy, guys. 0. Why? Good. Height is 0. Yeah. So if your height is 0, you don't have any potential energy relative to the ground. So your kinetic energy is given, right? They give you your kinetic energy. Kinetic energy at the bottom is 10 joules. The ball strikes the ground with 10 joules. So all you do at this point is subtract minus 10. 10 joules is your internal energy at the bottom. That's it. That's the answer. Any questions, guys? Very important. Make sure you ask me what your questions are if you don't understand. Very, very, very important. Yeah, sure. Also, there's a misconception I think I have to clear, by the way. The diagrams I drew with the blocks, right? Hopefully the block diagram was okay at giving you like an idea of what's going on, but I think there's a misconception because I drew the diagram with in a very simple manner. As you are falling, you are still losing energy due to friction. Because air resistance counts as friction. So it's not, so you, even before you hit the ground, you're losing energy. Even before you hit the ground. So I actually want to go back to the simulation here. Jonathan, can I erase it? So even before you hit the ground, you can see that your thermal bar is increasing. As long as you're touching a surface, you're losing energy. As you're falling, you're losing all energy due to air resistance. So this diagram that I showed you guys, if I can find it, this diagram that I showed you guys, a more accurate, like, I guess a less simple diagram would be, let's just erase this one block. Let's pretend this one block doesn't exist. Let's pretend there's also, as this ball is dropping down, there's also one block of internal energy as this block is falling down. Because the ball is still experiencing air resistance. So it's losing energy there. But yeah, the diagram is very simplistic, right? It's just to be very simple. A good example would be, I showed this to my other classes, would be this, right? A space shuttle re-entering Earth. Why do you think it's burning? Because it's hitting all those air molecules at such a high speed. So when space shuttles re-enter Earth, you need to make sure that they have a good enough heat shield. So that, let's not go there. Oh my God, I went to Colombia. Disaster. I looked up the cliffs. Oh no, let's not look at that. That was tragic. That was a tragic. Okay, yeah, but you can think of it like that. Also, it's also the reason why asteroids burn up, right? It's the reason why asteroids burn up when they enter our Earth's atmosphere, because they're hitting all these air molecules at such a high speed. There's a lot of friction, right? It's being, all that kinetic energy is being turned into thermal energy. All right. Next question, guys. Next practice question. Knowns.
Your mass is 25 grams.
Okay. Both of you are correct. I'm assuming that both of you were going to say the same exact thing.
Yeah, I was. He said I just let him speak.
Oh, yeah. Okay. It sounded like both of you were talking at the same time, though. All right. What else? What are my other knowns? Your kinetic energy at the bottom is 0.20 joules. Good. Height is 0.9 meters. And hopefully you guys are doing this in your head though, right? Even if you aren't participating, you should do this in your head. You have work right now, can you leave? Sure. I mean, there's nothing stopping you from leaving, right? I'll mark you here. I'll mark you here. Good luck with your job. Good luck with your job. Yeah, all the best. And you're finding out where your lost energy is, yeah. After you hit the ground. And you're gonna set up your equation the same exact way, right? So you drop this paper cup. And it reaches a height of 0. And you're gonna set up your total energies equations. Guys, I'm gonna skip writing these subscripts. I'm not gonna write top and bottom anymore. Hopefully you guys understand, like, if I'm writing at the top, it's being color coded. I mean, like at this height, right? And if I'm using this color, I'm using orange. I mean like at a height of 0, right? Actually, I'll write the subscripts. I'll write the subscripts, guys. Yeah, I'll just write the subscripts. So my potential energy at the top is mgh plus kinetic energy at the top. I don't have kinetic energy at the top. I'm falling from rest. My initial velocity is 0. I don't have kinetic energy. Also, I don't have any internal energy. I haven't even moved. I have not even moved. So you have M. Oh, I'm sorry. So your mass. What do you think I should do with my mass, guys? There's something wrong with my mass here. How do I usually measure mass?
kg.
kg. But my unit here is in grams. Now, if you remember to the beginning of the semester last year, we talked about unit conversions, where 1 kg would be 1,000 grams and 1 g would be 0.001 kg. But because this isn't like real class, you aren't here, I would actually emphasize unit conversion for the regions. But because you guys aren't taking the regions, I'm just going to show you the easy way to convert units. You guys should be able to convert units though. It's a very important skill to have. So if you don't really want to put an effort to do that, just Google it. Just write like 25 grams to kg, 25g to kg. And then Google will give you an answer, right? Google will give you that answer. No, you're not taking the regions. There is no physics regions this year. So Google says that that's 0.25 kilograms, right? Always make sure you convert units. So 9.8, 0.9. And from my previous classes that I remember, you get 0.2205 joules. Yeah, I said that if you were going to take the regions, I would make sure that you do it the correct way and not just Google it, right? Because unit conversion is important. I mean, it's important. Knowing how to convert units is important for any day life. Like, it's important for the future. It's important for now. It's important anytime. But I'm not going to stress that because you're not taking the regions. Because you measure mass in kilograms. You want to be consistent with your units. Think about it this way. Joules is basically Newton meters. What makes up newtons? A Newton is kg meters per second squared. So if you're working with joules, if you're working with meters, you must also work with kg. Your units must match. Units must match. But yeah, guys, if you do get a chance to like practice your unit conversion, you should. It's important. All right. So you have your total energy there. That's your total energy. You don't have any potential energy at the bottom because your height is 0. Most problems that I give you end with a height of 0, guys. There's only one question I've given you that where your height doesn't end in 0. And most regions problems end with a height of 0. So it just makes a lot of things really simple, right? Because you could just put like 0 here, 0 there. It doesn't really get too hard. And so your kinetic energy at the bottom is 0.20. So minus 0.20, minus 0.20. And I'm going to round it 0.02 joules. And that's your answer. So as this paper cup fell to the ground, it encountered air resistance. Because of air resistance, it lost 0.2 joules of energy due to internal energy, due to thermal energy. Questions about this, guys, before I move on to another practice problem. Another practice problem. How many of you guys are seniors?
I am.
Margin is, for sure. That's it. I think I remember one of you also being a senior, another one. You're a sophomore. I've had sophomores. I've had sophomores, juniors, and seniors in my physics classes last year. Did I ever have a freshman? I'm not sure.
Isn't it impossible to get for freshmen to take physics in
Possible.
freshman year?
No, it's possible. It's possible they'd be
Wait,
fine.
but in middle school, don't you have to go through don't like in middle school, don't they give you a test and you pass one, and when you go into freshman year, you basically skip one and you take the next one as after that?
No, I don't think so. I know that I took living environment or biology. I'm not sure. I'm pretty sure it's biology. I took biology in 8th grade. And
Mine was living, then I took chemistry, and now I have physics. That's how it worked for me.
Yeah, usually that's how it works in NYC high school system. And I took algebra in 8th grade. So I was qualified to take physics in freshman year, but I didn't. But you can definitely, it's possible. As long as you take like algebra and bio in 8th grade, you're fine. You're qualified, basically. You're eligible. You can go into chemistry, you can go into physics. It doesn't really matter. So I'm gonna do the knowns here for you guys. I didn't do attendance yet. I'm gonna do knowns for you guys. So this block, as this block slid down this hill, it lost. The energy lost was 100 joules, turned into heat energy. The question wants you to find out, what is the kinetic energy of this block at the bottom? So after this block has traveled down this hill, what is my kinetic energy at the bottom? You're given the force due to gravity. You're given the weight, right? The weight is 40 newtons, right? It's measured in newtons. You're given the height. The height is 8 meters. And you're going to set up the same exact formulas, right? You're setting up this same exact way. You're setting up the total energy at the top. I'm not going to write the subscripts anymore. Hopefully by now you know what I'm talking about, right? I'm measuring things at the top and I'm measuring things at the bottom. And my height at 0, I have a total energy. My potential energy at the top is mgh. What can you assume your kinetic energy and my Q at the top to be? 0. You're not moving. The block has not moved yet. You don't have kinetic energy. Also, because you have not moved yet, you haven't lost any energy yet. So mgh, but we know that fg is equal to mg. So we're just going to plug it in here. So fgh. Fg is 40, h is 8. So you get 320 joules. Okay. So now you know the total energy of this block. Now that you know the total energy of the block, you transfer it down here. 320. The P at the bottom, your potential energy at the bottom is 0. Your height is 0. Your block is at a height of 0. Your kinetic energy is what we want to find out. We want to find out what our kinetic energy is at the bottom. And we know that our internal energy at the bottom is 100. We lost 100 joules of energy due to friction. So we minus 100 on both sides and get 220 is equal to kinetic energy at the bottom. So as this block slid down this hill, we lost 100 joules of energy. We started with a total energy of 320 joules. And we ended up with a kinetic energy of 220 all the way at the bottom. Questions about this? Starting to like physics, which feels weird because you hate math. That is 100% very weird. That is definitely very weird. Because again, like physics is basically math. That makes you like math. Okay. I'm still pretty sure that students that hate math are, I'm pretty sure that the majority of students that hate math hate physics too, though. I'm still pretty sure. I'm really confident that, that's still the case, though. You might be outliers. In a data set, you might just be the outliers. You're like there's like a bell curve, and you guys are all the way at the outer edges of this bell curve. And the majority of people are over here. Just take the compliment. I'm glad. I'm glad they like physics. The people that said they do, though. Guys, let me know if you finished copying this down. I want to talk about one more thing before we go. Actually, I'm just gonna. This is your attendance poll. There's one more thing I want to talk about, though, guys. Actually, no, there really isn't. Guys, you have a 6-question homework. It's not like a break homework. It's literally just the normal homework you get. Actually, let me just clear responses a bit. So this is your attendance poll. Make sure to answer it, guys. after you finish copying this down, if you don't have any more questions for me, have a very, very, very great break, guys. Have a very great break. Enjoy your break. Bye, guys. See you later.